All right, Auto 2, good morning. We're going to be talking about spark plugs, service, spark plug wire service, resistance measurements on coil primary and secondary uh, resistance, and spark plug wire resistance and spark plug resistance. So let's get started. So what we'll do is I'll take the camera and we'll look at a number of things here really close first. First, here's three different spark plugs. One's an NGK, one's a Champion, one's an AC Delco. This Champion is basically brand new, and if you'll look at the center and side electrode where the spark jumps off right there, we always want to look at the condition, the shape. So the center electrode is round, but it has nice square edges, or sharp edges I should say. And the side electrode here on the bottom side is flat, and it's not cut off to one side. Whereas if you look at this very worn AC Delco plug, you'll see that the center electrode is very rounded and it's worn way down, so the gap is really wide. Let's see if it focuses. If you look at the side electrode, it's worn to one side. So if I take my pen, look over here on the whiteboard. So if we look at a center electrode like that with the porcelain here and a side electrode like this, okay, and we expect to see the spark jumping typically like this, up like that. So what we're looking at is, we want to look at this dimension. We call that the spark plug gap. Most spark plugs are 40 to 60 thousandths of an inch, okay? And but what we're looking at is, this will eat away and get rounded off over here. This will tend to get undercut like here as it wears. And as that plug wears, what you'll find is it'll begin to damage the ignition coil. So if you've got a coil here, what will happen to the ignition coil is it'll have to work too hard and it'll start failing. So we'll measure primary and secondary resistance on this and try and determine if that coil is good. But what I find many times is they'll measure good on their primary and secondary resistance, but then they won't fire correctly. So anyways, let's do a couple things. Let's take a spark plug gapper, and we'll get one that has a 40 thousandths dimension. This one's a little hard to read. That's actually says 44 thousandths right there. Sorry, it's a little hard to see. 44 thousandths. So what we do is we take this guy, we'll take our Champion spark plug, and we'll put this guy right between, put the tool right between, hopefully you can see it. And we're looking for it to have a little bit of pinch on there. So the 44 just slips through, the 45 is just touching, and if I go up to a 54, it doesn't fit in. So we want it to drag across there. So if I accurately, this is probably about 46 thousandths on that gap right there. And so I'm checking that again with my spark plug gap. If I want to change it, I can take this tool like this, and I can bend it like that, bend it away. Let's do it more like this. Bend it away, or I can bend it towards it to open or close the gap. Okay, so that thing's at about 46 thousandths, and which we would look up on ProDemand in the specifications to know exactly what it's supposed to be. And I can tell you right now it's probably really close. I'm going to pull off these meter leads and put on some alligator leads, and I'm going to put the meter to resistance. So I'll turn it to the Greek Omega symbol for resistance, and it automatically goes to an auto-ranging scale. The reason why it's showing a battery over there is my battery's probably on its way out. So if I push the blue button, I'm on a low range scale that will tone if I touch these two together. Okay. But when I'm measuring a high amount of resistance, I can't be on that tone setting. I've got to be on my auto-ranging setting. So auto-ranging just means it will either range to very high or very low, whatever it needs to do. So I'm going to touch the end of the side electrode here, or the center electrode here, sorry. And I'm going to touch, I'm doing this wrong, put this lead on, and I'm going to touch here, and hopefully you'll be able to read the meter in the picture there. I know the glare is kind of weird, so I'm going to touch the center electrode here, and then the center electrode here. And my meter is saying, sorry, 8.3 K ohms. There's a little K down at the bottom you can't see, but it was saying 8.3, and at the bottom it said K ohms, which is thousands of ohms. So this thing is reading 8.3 K ohms, or 8,300 ohms of resistance. That means that down the center of this electrode, in the middle, there's a resistor there. And that'll keep from us messing with radio reception and things like that. So it makes this thing, makes the spark have very low current but very high voltage to be able to jump that. And that's what we want in a spark, low current, high voltage. So I'm going to go ahead and put these leads back on. So that spark plug gave us about 8,300 or 8.3 K ohms, 8,300 ohms. And we've shown you how to use the gapping tool to gap it. Now what I'm going to do is I'm going to check the primary resistance. So on this coil, if I look right down in there, sorry, I'm trying to get it there so you can see it, and those two pins in there, I'm going to go ahead and take my meter leads and I'm going to touch each one of those two primary coil leads. And when I do, I get about 0.8 ohms, and that's really normal. We usually get somewhere really close to 0 to about 2 ohms through that primary coil, and if we remember, that's several hundred turns of fairly heavy wire. So it usually has really close, somewhere between 0 and 2 ohms. This is showing 0.9, so that's fine. We'll do the secondary resistance, which goes from one of these to the end of this, and I can pop this off. There's usually supposed to be a spring in here, and this one's missing. So we'll touch that terminal, we'll touch this terminal, and we should get several, quite a few thousand ohms, like sometimes 8,000 to 12,000 ohms is pretty standard. I'll go ahead and touch that lead right there, touch this lead right here, and I'm reading 5.29 K ohms, so 5,290 K ohms. That sounds pretty decent. Again, this is supposed to have a spring down the center, and it's just off of this one. But what I find on these coils is, again, they fail because spark plugs wear way down like this. The coil has to work too hard, and when the coil works too hard, it'll tend to fail. But I'll find I can take a coil and measure primary and secondary resistance, and it will measure just fine. It'll measure just fine, but the voltage, when it gets high enough, can actually sometimes arc right through the boot to ground on the cylinder head, or arc out the side of the case to the intake manifold under load. And load meaning when I'm going up quest to grade, or I'm towing something and there's a lot of cylinder pressure and the voltage has to go really high and the coil's trying really hard, and it'll take an easier path to ground and it won't fire the spark plug. Then you check engine light, that amber malfunction indicator lamp was on. You pull codes and it's got a PO303 or PO304, which is misfire cylinder 3, misfire cylinder 4. So next we're going to check the resistance of this coil wire. So I'll put this back down here. Put one lead inside the end here so I can touch that metal down in there. And I'll put the other lead on that metal there to touch down there. We should get several thousand ohms of resistance. It's reading 3.75 K ohms, so 3,750 ohms. This is resistor wire. It's made so that we don't interfere with radio reception. Maximum allowable resistance is about 1,000 ohms per inch. I'd say that's roughly an 18 or maybe 20 inch wire. So this could have up to 20,000 ohms, and it only had 3,000. So this wire is checking out good. This plug is checking out good. That is off this 2001 Dodge Ram we're going to do a little more testing with. And its cylinder 7 has had a little bit of a misfire and it's idling a little rough. The car only has 150,000 miles, and so we don't really assume that maybe there's a big engine problem. But when we did a compression test on it in my Auto 1 demonstration, it only had about 120 psi of compression. It should definitely have more than that. So I pulled the plug out. I sprayed a bunch of chem tool, hopefully to get some carbon off the top of the piston, maybe free up some valves, maybe free up some rings. Maybe the compression will come up and it'll start running a little bit better. I'm also going to clean the injectors, which the injector is going to spray at the back of the intake valve and hopefully clean any carbon that could be causing problems there. I don't know that for sure. So what I've shown you, though, is how we use an ohm meter to check wire resistance, how we use an ohm meter to check spark plug resistance, and also a gap to measure the gap and get it correct for whatever the specification calls for on that car. And we've measured primary coil resistance and secondary coil resistance. And again, secondary is from one of these pins, it doesn't matter which, to the center terminal. A DIS coil would be a little bit different on that. So that's, again, our resistance measurements and our coil, plug, and wire service. Every car has a spark plug. Every car today has a coil or multiple coils. Not every car has a spark plug wire. Most cars don't have spark plug wires anymore. That's off a 2001 Dodge Ram. Okay, that's it for now.